In this video, we're going to look at one more compound proposition and a couple examples of more exciting compound proposition truth tables. Okay, so the last of the compound propositions that we're interested in is called the biconditional. Biconditional, it looks similar to the conditional, except the arrow is going both ways. That's because it's implying that both must be true. It's saying if P, then Q. And it's also saying if Q, then P. So both of these statements are happening in the biconditional. So the truth table then is going to look like this. So we have no problem with both of them being true. That's fine. Or both of them being false. That's fine. The problem comes in when we have true implying false. We can't have true giving us a false statement. That's a problem. So for going in the direction of P, then Q, this one is a problem. When we go in the direction of Q, then P, this one's a problem. So this is the truth table for the biconditional. Only when they're both true or both false does it work. They also use the terminology if and only if when they look at the biconditional. So down here, when they say I'm at home and then it is raining, those are our two propositions then. I am at home if and only if it is raining. So both have to be true, or both of them are false. That's the only cases that work. Here's some alternative versions of that in the English language. I'm not going to get too hung up on that. We're going to try to stick very closely with if and only if. So let's look at some more examples of truth tables. Okay, a little bit more complicated. And this time we're going to have a third variable on this one. Ooh, really exciting. Okay, so we haven't worked with a third variable. So this case, here's how the truth table is going to happen. We're going to have truth 4 times and then false 4 times. This one's going to go true, true, false, false, true, true, false, false. And then this one's going to switch true, false, true, false, true, false, true, false. All right. So first thing we want to find is P or Q. Then I want to find not R. And then I will find P or Q, then not R. Okay, so let's start with P or Q. So I'm ignoring the column with the R. I'm just looking at the first two. And in this case, whenever there's a single true, it's going to work. So true, 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 true. And then the bottom two, those are the first time we see false because they both are false. All right. Not R, I'm going to swap all of them. So false, true, false, true, false, true, false, true, right? I was looking at, just so we're clear, this column, and I was switching them all. Okay, so now we're going to look at this implying this. So remember, the only problem we have is if we start with true and end with false. So this won't work. This one's good. Nope, that's not going to work. This one's good. Nope, not going to work. This one's good. This one's good. And that one's fine. So there we go. There's what the truth table would look like for that one. Okay, so for this one, I don't think we need the big column for this one. I just realized that. So use a truth table showing the inverse is not equivalent to the conditional. So the inverse is when you negate both of them. Conditional is when it's just P implies Q. Okay, so we don't need the R column. And I don't need these bottom 4 either. Okay. What I do need, I'm just realizing I need not P and not Q. Okay, so here, sorry. Hopefully you didn't scribble over yours just like I did. Trying to erase, but my computer is having trouble keeping up with me. There we go. Finally caught up with me. Okay, so here, instead of R, I'm going to call this not P. And this will be not Q. This will be not P implies not Q. And this will be P implies Q. So I'm going to compare those two. Okay, so let me start with P and Q. So true, true, false, false, true, false, true, false. Okay, here I'm going to do the last column just from those two first. Okay, so that's going to be true, false, true, true. Okay. All right, so now I'm going to do the middle ones here. So not P, that's going to switch the first one. So false, false, true, true. Not Q, that's going to switch the second column. So false, true, false, true. Okay, and now we're looking for the implication. So false implying false, that's fine. False implying true, that's fine. True implying false, nope. And true implying true, that's fine. Okay, so I'm looking at the last two columns and they do not match. That means that they're not equivalent, which is what they asked us to show. So we did it. Yay, we're amazing.